So this is our first section, 14.1, on just describing waves. So first I'm going to talk about wavelength and amplitude, which I already mentioned 5 seconds ago. So waves are made up of crests and troughs. Like I said, crests at the top, troughs at the bottom. The wavelength lambda is the distance from one crest to the next, or from one trough to the next. So enough, again, to get one full wave, or one full cycle. The amplitude A is the distance from the center of the wave to the top or bottom of a trough or a crest. So from the middle to the top, middle, down. Okay? So again, this is all what I just said on the other one, just going through it in a little more detail. Now, before I go here, with this one, like I said before, wavelength and amplitude is measured as a length, so as a distance, right? Meters, micrometers, whatever we're using. But here, frequency and period are measured as time. Okay, so they're similar ideas, frequency and period as wavelength. They're similar somewhat, but these are measured in time, the other ones are measured as a length. So the frequency of a wave is how many waves are sent out each second. Okay, so after 1 second, how many different waves are set out? That's frequency. Frequency is measured in hertz. So 1 hertz is 1 wave per second. Excuse me. So, oops. Oh wow, that's really out. So hertz is equal to, oops, waves per, this is awkward, second. Okay. So the period t of a wave is the time taken to complete one wave to pass a point. So the period is similar to wavelength, only period is measured in time instead of distance. So a wavelength would be from one crest to another. Same with period, from one crest to another. One measured in time, one measured in distance, in length. Okay? So in this example, the frequency is 3 cycles per second, right? This distance, or this, amount here is 1 second. I have 3 cycles in a second, so then my frequency is 3 hertz. Okay, 3 cycles per second. And then the period here would be 1/3 of that. Right? So the period would be 1/3 of a second, because that's how much time it takes to complete one cycle, is 1/3 of a second. Does that make sense so far? It'll probably make more sense once you start working, going through the formulas, which I'll talk about, and it'll make it a little bit easier. And here are our formulas. So frequency and period. So the frequency is equal to 1 divided by the period. Okay? Again, frequency measured in hertz, period measured in seconds. So F is equal to 1 over T. So then the period is equal to 1 over the frequency. Right? So T is equal to 1 over F. So for our first example here, a wave has a period of 10 seconds. What is its frequency? So if I'm trying to find frequency, I'll use this formula here, right? So to get the frequency, I just take 1 divided by my period, which is 10 seconds. So the frequency in that case would be 1/10, 1 over 10 hertz. So that means it's going to be 1/10 of a cycle per second. So I'll try and do this, hopefully it won't be too messy. So frequency is equal to 1 over the period, which in this case is 10. So my frequency is 1 over 10 hertz. 1/10 of a cycle per second. And then the second one there, a wave has a frequency of 500 hertz. What is the period? So if I'm trying to find the period, I use this one here. So 1 over my frequency. So my period would be 1 over 500. So period is t is equal to 1 over 500 seconds. So what this tells me is that one wavelength, so one complete cycle, right, one all the way through here, one complete cycle will happen in 1/500th of a second. Okay, so that's what that tells me. That's what period means. And 1/500th of a second is one cycle. Does that make more sense now? Well, for the rest of you, yes. I'll come by and then help you with that afterwards. So, now, stepping on stuff. Wave speed and energy. So the wave speed is the rate at which a crest of waves travels along. So if, for example, I guess the easiest way to picture this would be water. If you're at a beach or even just, have a tub of water or something like that in a pool, you can, splash your hand in it and you can watch a wave move, right? You can watch it go across the water. That's what that wave speed is. So if you look at one crest, let's say, and just watch it moving along, that's the wave speed. That's what we're looking at. So for example, sound waves travel at 330 meters per second through air. Okay? So if me talking right now, if I could, pick out one crest of the wave of my voice, right? I could see it traveling at 330 meters per second, just watching that one part move. Okay? That's what wave speed is like. So wave speed can also be thought as the speed at which it transfers energy from place to place. Because more than just sound, light, for example, or radiation from the sun, which gives us our light as well, travels as a wave, and you can determine the speed of that by just watching one crest traveling through. Now, this is actually a very small section of the chapter. In fact, I think it's like 3 paragraphs in the entire chapter. So that's all I'm going to really say about this. For the most part, for wave speed, if we want to find the speed, you just need to look at really the frequency, or the period, because that would tell you the distance or the time from one crest to another, which would be the same as that crest moving along, right? So they're very similar, easy to find. So now we'll talk about the 2 different kinds of waves, which I already mentioned, so I'll quickly go through this. Transverse waves, right? So waves that go up and down like this. And then longitudinal waves, which are straight across, but you have this oscillation, through it, and you have little parts that are compressed, so closer together, and other parts that are expanded, which are farther apart. So again, sound would be an example here, or ripple in water, an example of a transverse wave. So I've already talked about that, and that is it. So that's the first section, just on describing waves. Again, most of it should be review from what we've done already with sound and light. Okay? So it shouldn't be too much more difficult. The only thing that we're adding in now are the formulas for, say, frequency and period. Right? That's all we're really adding in from what we did already with light and sound. So are there any questions about this first section? Yeah? You have so many. Okay, then I will come and help you with that after. So then, if nothing else,